Hello friends, welcome to Mathematics Portal, and today we are going to discuss about the mappings or functions. You can see that there are two definitions. The first definition is, let A be a set and B be a set. Then a relation f from A to B is called a mapping or a map or a function from A to B if for each element x in A there is exactly one element y in B such that x is in relation f to y. The point is to be noted that each element x in A is related exactly one element y in B, and this can be written in the form like that. And the second definition tells us that a function f from a set A to a set B is a rule that associates to every element of A exactly one element of B, and this can be written as this, and that means fx equals to y where x belongs to A and y belongs to B. Now from this some important things comes out. The first is, if f be a map from A to B, then the set A from which the mapping is defined is called domain, and a set to which mapping is defined is called codomain. You can see that f is a mapping from A to B, so A is called domain and B is called codomain. And according to the second definition, mapping this can be written as f of A equals to B, where A belongs to A and B belongs to B. And from this, the element B is called the image of A under this mapping F, and image is also known as the F image, whereas the element A is called pre-image of the element B. Now we learn about the set notations. According to the second definition, if F be a map from A to B, then this can be written as f of A equals to B, where A belongs to A and B belongs to B. But according to the second definition, a mapping can also be written as the ordered pair, because the first definition tells us that a mapping is a relation from A to B, and we know that a relation R between two sets is a subset of the Cartesian product of those sets. So R is a relation from A to B, so R is a subset of A cross B. So how we have to define this mapping in terms of ordered pairs? Suppose if we have a set A having element A1, A2 and A3, and suppose another set B having the element B1, B2, B3, then we have to find A cross B, which is equals to A1 B1, A1 B2, A1 B3, A2 B1. So we have find out the ordered pairs of A cross B. So as I said, a relation R is the subset of A cross B, and a mapping from A to B is also be a relation from A to B. So this mapping, suppose F be a mapping defined as A1 B1, A2 B2, A3 B3. So this is the subset of, you can see that is the subset of A cross B. So this mapping is also written in terms of the ordered pairs. So what it means? So it means, as you can see, that the first element of this mapping is the ordered pair. So first ordered pair means f of A1 equals to B1, f of A2 equals to B2, f of A3 equals to B3. So here the elements, this element is called the image and this element is called the pre-image. Similarly, these are the pre-images and this is the image, this is the pre-image and this is the image. So now second thing is comes out the set of A1, A2, A3. This is called the domain, and the set of these images B1, B2, B3 it is called the range. So you can see that there is one more definition is which is of the range. So the range is the set of the all images which is called the range. So this is the second notation of a mapping. We can define a mapping in terms of ordered pairs. So the first coordinate of the ordered pair is called the element of the domain, and the second coordinate of this ordered pair is the element of the range. So the set of a1 a2 a3 is called the domain. The set of b1 b2 b3, which is the set of images, is the range. And now we're going to discuss how to recognize a valid function. As I said that every function can be written in the ordered pairs, and these ordered pairs denoting the images and pre-images of a mapping. So you can see that there are two functions. The first function, which is equals to x comma a x comma b y comma c y comma d y comma e, and the second function is 3 comma 4 2 comma 4 and 1 comma 3. These can be written in the ordered pairs. So according to the first and second definition, we says that a mapping is a function from a set A to the set B which associates each element of A exactly one element of B. That means a element have a unique image in the set B. In the first function you can see that x has the image A. Again you can see that x has another image B. So you can say that x has two images. But according to the first statement, which says that x has a unique image in B, so which does not fulfill our definition, so this cannot be a function. And you can again see that there is a element y which has a one image C, one image D and one image E. So this element y has three images, which cannot be possible. So first function which is given here is not a function. This is not a function. Now you can see that there is another function which is equals to 3 comma 4 2 comma 4 1 comma 3. You can see that there is a element 3 have the image 4, element 2 have a image 4, another element 1 have a image 3. These every element 3 2 and 1 have a unique image 4, that is f of 3 equals to 4, f of 2 equals to 4, f of 1 equals to 3. So this element have a unique image 4, this element have a unique image, this element have a unique image. So this function satisfies our definition, so this should be a function, a valid function. So this is the difference between this is how to define, how to recognize a function which is valid or not. And now we have another example of this mapping. You can see that there is another mapping defined here. This can be written as f of 2 equals to 3, f of 3 equals to 4 and f of 2 equals to 0. Now we can write the domain and range of this. You can see that the domain of this is defined 2, 3 and 2, and range is defined as 3, 4 and 0. But you can see that the element 2 comes 2 times in a domain. So this is not possible because our definition says that a element has every element in A has a unique images in B, but here the element 2 have two images. 2 has the image 3, 2 has the image 0, and also you can see that the 2 comes 2 times in a domain, so this is not possible and this is not be a valid function. So this is not a valid function. So that is it in this video. If you like our channels and our videos, so please subscribe Mathematics Portal and like us on Facebook and Instagram. Thanks for watching. See you again.